Hi, I'm Joe with Neoti. We're here at the Neoti Tech Center with another Tech Talk. And today we're going to talk about bit depth, or sometimes it's called color depth, sometimes it's called grayscale depth, what that is and what it means to us with direct view LED screens. So, the human eye can see about 10 million colors, right? That's what we have the ability to see, and 8-bit video, which is what is most typical in the world today, displays 16 million colors. Well, how does it display 16 million colors, and how do I even know that? Well, it's pretty simple. Each color on a pixel is composed of red, green, and blue. It's a mix of red, green, and blue. Well, with 8-bit video, you have 256 shades of red, 256 shades of green, and 256 shades of blue for the system to pick from to display that color on that one particular pixel. And so that's what 8-bit video is. 10-bit video actually jumps that up. It jumps that up to 1024 shades. So quite a bit more ability for it to choose which color to push through to that pixel based on what it is deciphering, or the frame you're trying to give it, right? And so how does that look on screen? Well, we have 16 million colors in 8-bit video and 10 million for our eyes, so why would we ever need to go to 10-bit or 12-bit? Well, if you take a picture or a video of a sunset and you have the sky, and on this side of the sky it's blue, and as it fades to the right side it's red and green and yellow and some other colors, right? Purple, some other colors, but the gradient is very gradual, right? When you have gradual color gradients like that, in 8-bit video, we can still get times where the software and the hardware doesn't know how to handle those subtle gradients, and it just leaves some banding, right? It assigns that band a color, but it assigns the next band next to it a color, and there's no sort of in-between, so it's like a hard band. Well, 10-bit and 12-bit video gives it many more options, right? 4 times, 8 times, 16 times as many options to choose from to give those subtle gradients a more natural color, so it's more of a smooth flow, right? So there's less banding. So that is why you would want to go 10-bit and 12-bit. If you have a 10-bit and 12-bit video and you're feeding it to the LED system, and the LED system is set to only receive 8-bit video, which is typical, then it will still display the video, but you'll still get the banding on the screen because the system has to be set to receive that 10-bit and 12-bit video. And so what we'll do is we'll set the system for 10 to 12-bit video. The compromise there is that you have to throw a little bit more hardware at the install. What does that mean? Well, the pixel load capacity per port gets cut in half, which means each port from the controller can only drive half as many panels as it used to when you go from 8-bit to a higher bit depth, like 10-bit or 12-bit. And so that means there's more wiring, probably twice as much wiring from the controller to the screen. And there might even be twice as many controllers as you had before, because you're definitely using twice as many ports, right? And so there's some hardware considerations. If you know you're going to set up a 10 or a 12 or a 14-bit system and it's always going to be there, then you just have to throw some more hardware on it at the front end. If you'd like some more information about load capacity, low capacity per port, you can check out our other Tech Talk video on that called Load Capacity. Thanks for watching.